Here we are at our example 3 from our 4.2 set of notes. We're asked to graph this quadratic in vertex form. And we're going to go ahead and start off by identifying our A, H, and K. So our A value is that 1/2 in front. The H value, again, we always just take the opposite of what's inside this parentheses. So since it says -1, our H value is actually normal 1. And our K value, we take just as it is. So K in this case comes out to be -3. And as a result, for our parabola, because A is positive like that, you should see a U going up like that, just like standard form. But our vertex we do now know as 1, -3. So going ahead and plotting that, we have 1, -3 located right there. And our axis of symmetry, again, is always passing through our vertex. So that is x equals 1. Don't ever forget to write down the x equals, because, again, that is a line that you're describing. And so that, again, is that axis of symmetry acts as our mirror. So that's pretty useful to have for reflecting our points. So x equals 1. Now we have to go ahead and determine what is our y-intercept. And to do that, we're always going to go ahead and plug in 0 for the x value. And then we just have to determine what does that in fact come out to be. So we have y equals 1/2 times 0 minus 1 squared minus 3. So 0 minus 1 inside the parentheses comes out to be -1 squared. -1 squared comes out to be regular 1. And then 1/2 times 1 comes out to be just 1/2. And so our y value comes out to be -2 1/2. So when we plug 0 in, we got a y value of -2 1/2. So that would be about there on our graph. And then when we reflect that, notice how it's 1 unit to the right, or to the left of your mirror. You would have to go 1 unit to the right of the mirror, giving us that reflection coordinate of 2, -2 1/2. Now we're going to go ahead and plug in another value of our choice. Maybe we'll just go with the next closest one. So we could use like +3 because we haven't yet used that. And then we'll go ahead and do our little bit of GEMDAS to determine what is, in fact, that y value. Clean this up a little bit. All right, so y equals 1/2 times 3 minus 1 squared minus 3. So 3 minus 1 comes out to be 2. And then 2 squared gives us 4. 1/2 of 4 comes out to be 2. So then our y value comes out to be -1. So at 3, we got a y value of -1. So on the graph, there is our y value, or our coordinate rather. And notice how our reflection point is, or notice how our point is 2 units to the right of the mirror. We're going to go 2 units to the left of the mirror, put a little dot there, giving us our reflection point. And now we're just going to go ahead and label that. So that is currently at -1, -1. Now we can go ahead and create our U shape, and we would see a graph that does something like that. Now, going back really quickly to this A value, that A value, notice how it's a fraction, 1/2. What that would do is, because it's a fraction that's less than 1, you would see, instead of a parabola that's a little bit more of like the parent function, you would see, since it's a fraction that's less than 1 like that, it's going to widen, okay? Whereas, like with example 2, when the A value was -2, that A value is bigger than the absolute value of 1. So in other words, if you were to plug that value in, you'd get a positive 2. You would see your graph begin to narrow and what we call stretch. Okay. Your Algebra 2 teacher will talk more about that, though. For our domain and range, though, but I just wanted you to be aware, like if you have a fraction like we do here, you're going to see that widen occur. Okay. Whereas if your A value is bigger than 1, you're going to either see it become really thin, up or down. Doesn't matter. Okay. So for our domain, we have negative infinity to positive infinity. And our range here, looks like the smallest y value there is at negative 3. And then it goes on forever. Can't ever obtain infinity, so he has a parenthesis, but the vertex gives us that y value, so you can be negative 3, so we have a bracket there. Again, though, that is example 3 from our 4.2 set of notes.